At this very moment, under the deep blue waters of the Mediterranean Sea, a concealed volcano is steadily expanding. After 4 centuries of near silence, it is beginning to stir again. Only 4 miles from Santorini, counted among the most visited islands on the planet, researchers have identified something deeply unsettling. A vast magma chamber has been forming for almost 400 years. It contains enough molten rock to fill roughly 500,000 Olympic-sized swimming pools, and it continues to increase in volume year after year without any pause. In January 2025, the Earth started trembling. More than 30,000 earthquakes struck within just 30 days. The Greek government announced a state of emergency. Schools were closed. Around 11,000 residents left the island. Yet what truly alarmed scientists was discovered beneath the surface. Santorini and this submerged volcano are not independent systems. They are linked, operating together, drawing from the same deep magma reservoir. About 20,000 permanent residents live there, and between 3 and 12 million tourists visit annually, all situated above a volcanic system recharging itself for an eruption that could rival the catastrophe that once erased an entire civilization. Is Santorini positioned atop a geological time bomb, or has the countdown already started? When people imagine a volcano, they usually picture a towering mountain erupting with lava, ash, and fire visible from miles away. However, the most dangerous volcanoes on Earth are often those hidden from sight. They lie beneath the ocean's surface, building pressure and darkness, far from human awareness. And they are far more numerous than volcanoes on land. Kolumbo is one of these unseen giants. Located about 4 miles northeast of Santorini, it rests 1,600 feet beneath the Mediterranean surface. There is no smoke, no visible crater above water, no obvious warning signs for tourists enjoying wine along the caldera cliffs. Just calm blue sea concealing a geological threat. Its position is not accidental. Kolumbo lies along the Hellenic volcanic arc, one of the most geologically active regions in the Mediterranean. This is the same tectonic zone responsible for the devastating Thera eruption around 1600 BC, the explosion that triggered tsunamis across the eastern Mediterranean and nearly wiped the Minoan civilization from existence. Kolumbo is not an isolated cone. It belongs to a volcanic field made up of at least 25 submarine cones aligned in a chain stretching northeast from Santorini, an underwater mountain range capable of destruction that most people have never heard of. The forces driving this system are constant and unrelenting. The African tectonic plate is descending beneath the Aegean plate at a rate of about 1 inch per year. As the African plate sinks into Earth's mantle, it melts. The molten material rises toward the surface, collecting in chambers beneath the seabed. This process does not stop. The pressure does not dissipate. Magma continues to accumulate. For years, scientists studying the region faced a critical limitation. Seismic data confirmed volcanic activity beneath Kolumbo, but they could not determine the chamber's true size. Conventional monitoring methods could not penetrate the seafloor with enough clarity. Researchers across institutions kept asking the same question: how much magma is actually down there? How large has this hidden reservoir become? Answering that question required groundbreaking technology. And when scientists finally obtained a clear image of what lay beneath Kolumbo, the results surpassed their most alarming expectations. The Mediterranean has a long history of volcanic disaster, and the area around Santorini contains some of its darkest chapters. Around 1600 BCE, the volcano known as Thera erupted with extraordinary violence. Experts estimate that the blast released energy equal to hundreds of nuclear bombs detonating at once. The eruption column shot high into the stratosphere. Tsunamis spread throughout the eastern Mediterranean, destroying coastal communities hundreds of miles away. Ash blanketed entire cities. The Minoan civilization, one of the ancient world's most advanced societies, never fully recovered. Their palaces collapsed. Trade networks disintegrated. Within generations, a flourishing civilization faded almost entirely from history. One eruption reshaped the destiny of an entire region. That is the scale of power contained within this volcanic system. Kolumbo exists within the same geological zone, influenced by the same tectonic dynamics, building pressure through identical mechanisms. Kolumbo's last eruption occurred in 1650 CE. Historical accounts describe terrifying scenes: pyroclastic flows, superheated currents of gas and rock moving at hurricane speeds, raced across the sea surface and reached Santorini shores. Toxic gases spread across the island. 70 people died. For that time period, with a much smaller population, the impact was devastating. Nearly 400 years have passed since that eruption. Kolumbo has remained quiet. No explosions, no visible disturbances above its crater. But volcanic silence is misleading. It does not indicate safety. In many cases, it means pressure is steadily increasing. Researchers understood this. They suspected something substantial was forming beneath the seafloor. But suspicion required confirmation. That confirmation came in 2022, and it changed everything. In October 2022, a study published in the journal Geochemistry, Geophysics, Geosystems revealed findings that sent shockwaves through the volcanology community. A research team led by geophysicist Keaton Crouchett at Imperial College London managed to visualize Kolumbo's internal structure. They used an advanced technique known as full waveform inversion. Traditional seismic monitoring could detect activity, but could not generate precise images of the magma chamber. Full waveform inversion changed that. Similar to a medical ultrasound, researchers sent sound waves into the ocean floor. These waves traveled through rock beneath the seabed. They moved quickly through solid material, but slowed dramatically when passing through molten magma. By measuring variations in speed across thousands of data points, scientists constructed a three-dimensional image of the subsurface, essentially an X-ray of Earth's interior. The resulting image revealed a previously unknown magma chamber. The chamber extends from roughly 1.25 to 2.5 miles below sea level, about 2 to 4 kilometers in vertical depth. It spans approximately 2,000 feet or 600 meters across. While magma chambers are common beneath volcanoes, what alarmed scientists was the sheer volume of molten rock and the rate at which it was increasing. The total accumulated magma volume measures around 1.4 cubic kilometers, about 1/3 of a cubic mile. That amount could fill more than 500,000 Olympic swimming pools with molten rock at temperatures exceeding 1,800 degrees Fahrenheit, over 1,000 degrees Celsius, hot enough to instantly vaporize nearly anything. More concerning than the volume was the growth rate. Since 1650, Kolumbo's magma chamber has been expanding by an average of 141 million cubic feet per year, around 4 million cubic meters annually. For nearly 4 centuries, without interruption, magma has continued to build. If this rate persists, researchers estimate that within 150 years, the chamber could contain 2 cubic kilometers of magma, the same volume expelled during the 1650 eruption. In other words, the volcano is gradually recharging itself for an event comparable to what occurred 400 years ago. Scientists describe the system as capable of highly explosive activity, similar in style to the 2022 Hungatonga eruption, which generated tsunami waves up to 66 feet high and sent an eruption column into the stratosphere visible from space. Kolumbo lies only 4 miles from Santorini. The island hosts around 20,000 permanent residents and welcomes roughly 3.5 million tourists each year. Beneath them, the magma chamber continues to grow, adding 141 million cubic feet annually. The geological clock keeps ticking. On January 27, 2025, monitoring stations detected unusual seismic activity about 6 miles northeast of Santorini, directly above the Kolumbo volcanic field. What began as isolated tremors escalated rapidly. Within 30 days, over 30,000 earthquakes struck the area between Santorini and the nearby island of Amorgos. The University of Athens reported more than 15,000 quakes in just 15 days, unprecedented for the region. The strongest reached magnitude 5.2, powerful enough to crack walls and knock objects from shelves. On February 6, 2025, the Greek government declared a state of emergency, lasting until March 3rd. Schools closed. Residents were advised to drain swimming pools to prevent structural damage from sloshing water during tremors. Approximately 11,000 people evacuated. Tourism collapsed overnight. Hotels faced mass cancellations. The central question remained: was Kolumbo about to erupt? In November 2025, a study published in Nature provided answers. Researchers determined that Santorini and Kolumbo are interconnected, fed by the same deep magmatic reservoir miles beneath the seafloor. Using artificial intelligence to analyze more than 25,000 earthquakes, scientists discovered that beginning in mid-2024, Santorini's caldera had begun inflating. Magma was pushing upward, but its source was linked to a mid-crustal reservoir beneath Kolumbo. Instruments recorded the seafloor above Kolumbo sinking by 13 inches, while Santorini's surface rose more than 4 inches. Magma was shifting between the two systems in real time. The volcanoes were effectively breathing together. This realization transformed regional risk assessments. Activity in one system directly influences the other. Kolumbo is not the Mediterranean's only hidden threat. About 109 miles south of Naples lies Marsilli, a massive submarine volcano in the Tyrrhenian Sea. Stretching roughly 43 miles long and 19 miles wide, it is larger than Mount Etna. Rising nearly 10,000 feet from the seafloor, its summit lies just 1,500 feet below the surface. Italian scientists warn that Marsilli's unstable structure could trigger tsunamis if parts of it collapse. Simulations suggest waves could reach the Aeolian Islands in 10 minutes and strike Calabria and Sicily within 20 minutes. The Mediterranean lacks a comprehensive tsunami warning system. Distances are short. Response times would be measured in minutes. Following the 2025 crisis, monitoring efforts intensified. In December 2025, the research vessel Meteor launched a Santorini expedition equipped with advanced submarine sensors. Seismographs, pressure gauges, and satellite systems now track activity continuously. New instruments have been installed inside Kolumbo's crater, 1,600 feet below the surface, collecting data unimaginable just 5 years ago. Scientific understanding has advanced rapidly. International collaboration among Greek, Italian, and British institutions has strengthened. Yet one reality remains unchanged. Kolumbo's magma chamber continues expanding, adding 141 million cubic feet each year. Tourists will return. The white buildings along Santorini's caldera will fill again. Sunsets will be photographed. Life will continue, but 4 miles offshore and 1,600 feet beneath the sea, magma keeps rising. The chamber keeps enlarging. The system keeps charging toward a future eruption that history suggests is not a matter of if, but when. Beneath waters many consider paradise, a geological clock that began ticking in 1650 continues its patient countdown. And every year, it moves 141 million cubic feet closer to zero.